Welcome back, everyone. Today we're going to talk about trig identities and how we use them to simplify expressions. It's kind of hard to see on the calculator here, but it says if I were sine squared, terrible grammar, and you were cosine squared, together we would be 1. It sounds corny, but it's true. There are a few trig identities and properties you must memorize, and we're going to use those to simplify expressions. Okay? They seem confusing because there's not one way to simplify these answers down. There's multiple ways you can do it. You can do the problem in any order you want. But if you know the properties, you'll get the same answer. It's going to seem frustrating at first because, there's no one way to do the problem. But it gets easier with time. People have trouble with some notation. I'm never going to write sine theta to the fourth like this. I'm going to instead write it like this. This does not mean sine to the fourth times theta. It means sine of theta all to the fourth power. This isn't a problem, this isn't anything to work out, but you just have to recognize this, that in this problem, it's the entire sine that's being raised to the fourth, not just the theta that's being raised to the fourth. Now, like I said, these two things are not the same. Here, I take the angle to the fifth power and then take the cosine. Here, I take the cosine of the angle, get an answer, and then raise it to the fifth power. So be aware of that. Especially in calculus, we get into this problem and people have trouble with it. These two things are not the same. Okay? Quotient identities. We kind of know these already. Tangent is sine over cosine because it's y over x. Cotangent is just the reciprocal of that, cosine over sine. Why am I showing you this? Why is this an identity? Because if we can rewrite everything in terms of sine and cosine, it's a much easier problem. These are the other identities that you should know. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Secant and cosine, cosecant and sine, they all match together. Cotangent and tangent. These are things you already know. So let's simplify this problem. It looks really ugly. So I'm going to try to turn everything into sines and cosines. I'm going to get rid of division. So I'm going to say this is sine theta over cosine theta. That takes care of the tangent theta. Secant squared. Well, secant is 1 over sine theta squared. Secant is 1 over cosine theta. But instead of dividing by 1 over cosine theta, I'm going to multiply by secant theta. No, I don't like that. I'm going to leave it as 1 over cosine theta. Because my point here, dividing by 1 over cosine theta is the same as multiplying by cosine theta. I said it wrong. I apologize. That's right. That's right. Because I just flipped that and put it back on top. So now, let's clean this part up. 1 squared is still 1. Not sine of theta squared, but sine squared of theta. Sine of theta over cosine theta. Cosine theta over 1. Look for things that will cancel. Well, this sine will cancel with one of those sines. This cosecant will cancel with that cosecant. So what's left? Well, the only thing I have left on top is 1. The only thing I have left on bottom is sine theta. What's another way to write 1 over sine theta? You would never leave it as 1 over sine theta. 1 over sine theta is the same thing as cosecant theta. So the answer to this problem, if you simplify it all the way down, is just cosecant theta. That's not the only way to do that problem. It's the way that makes the most sense, but you could do it other ways. Here are the big properties you have to memorize. These are called the Pythagorean identities. Sine squared plus cosine squared is 1. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. You have to have these memorized. It's kind of like the Pythagorean theorem. Things you just have to know. By the way, these can be manipulated. If I wanted to put the cosine squared on this side, I could do that. I would say sine squared equals 1 minus cosine squared. I can manipulate the properties any way I want to make them fit what I'm doing. Let me show you what I mean. I'm going to simplify the same problem but in two different ways. On this side, I'm just going to change everything to sines and cosines. So tangent squared is the same thing as sine squared over cosine squared times cosine squared plus cosine squared. So help me do some cleanup. This cosine squared and this cosine squared will cancel. If I multiply straight across, I get sine squared of theta plus cosine squared of theta. What is sine squared plus cosine squared? Well, that's a property. The answer is just 1. How about another way to do this? Think about algebra. What do you see that these two things have in common? They both have a cosine squared in them, so I can factor out the cosine squared of theta. That leaves me a tan squared of theta plus, if I factor cosine squared out of cosine squared, I have 1. I see tangent squared plus 1. That's the same thing as this, 1 plus tangent squared. What can I do with the 1 plus tangent squared? I can replace it with secant squared. So this becomes cosine squared of theta times secant squared of theta. Well, that doesn't look like it helped me at all, but it does. Remember, secant squared of theta is the same thing as 1 over cosine of theta. And because they were squared, the cosine is squared. Now it's really obvious. What do you see? Cosine and cosine will cancel. What are you left with? 1. So I did the same problem, two completely different ways. And I used two completely different Pythagorean identities. But I still ended up with the same answer. The big thing to take away from this unit, you have to know the Pythagorean identities. And you have to be able to problem solve. Think of ways to solve the problem that might be different than somebody else. There's not just one way. You will get good at this.